Welcome to class. Today, we're going to start talking about some tools for analyzing dynamical systems. First up, slope fields. So, up here, I've got a first-order ODE, and we can write all of these as du dt equals some function of u and t. Or in other words, since this is first order, this is really highest order derivative equals everything else, where I've just isolated my highest order term. And when I write it this way, the right-hand side here is what we call the slope function for that differential equation. And a slope field is a tool that helps us visualize what the slope function actually looks like. Essentially what we're going to do is we're going to find a grid of points in the xy plane, and we're going to evaluate the slope function at each of those points, and then in the plane draw a tiny little snippet of the tangent line there. So let's first take a look at an example of how do I build one of those, and then we'll see how can I use it to understand more things about the system. Well, here I've got an example that dy dx equals x squared minus y. Notice that everything except for the highest order derivative has been moved to one side. So this tells me over here that my slope function is x squared minus y. And that is a multivariate function, x squared minus y. So what I do is I go into the xy plane here, and I'm going to pick a grid of some points. And I've got a couple that I want to look at here. Let's look at the origin together. Let's do the point 1, 0. Let's do the point 0, 1. Let's do the point 1, 1 all together. So f of 0, 0. Well, that's just 0. So what I'm going to do is at the origin, I'm going to draw a tiny little piece of line with slope 0. There it is in blue. Next, I'm going to check 0, 1. So I plug 0 in for x, 1 in for y, I get -1. And now I'm going to draw a tiny little piece of line with slope -1. Like this. And I'm going to continue this process. So when I plug in 1, 1, I get 1 minus 1, or 0 again. When I plug in 1, 0, I get 1 minus 0, or 1. So I'll have another little flat line here at 1, 1, and this time a slope of +1 over here. And looking at this picture so far, it's confusing to see how this is helpful. And truthfully, it's because we need a lot more points to see the bigger picture. So I'm actually going to swap over to technology here.
Okay, let's quickly recap the steps. Using our slope function, we plug in a point. And here I chose the point 1, 1, which evaluates to 0. So at the point 1, 1, I draw a small line segment with slope 0. And I repeat this process across however many points I like to create the slope field as a whole, which is a lot easier to do on a computer like this. We can learn a lot now about the dynamics of the system by looking at the slope field. For example, if I connect the dots between all of the 0 slopes, well, that's just the nullcline, or the equilibrium, for the solution. And I can find other isoclines by just matching different equal slopes. But here's a really cool one. If I was given an initial condition, say like this one, if I just trace out the motion from the slopes, I can kind of see what the system is going to do based on that initial condition.